So here we're going to be talking about the two fundamental parts of each graph and equation. Every linear equation, every equation of a line has these two parts, the slope and the y-intercept. And we're going to see that it's going to be really easy to go from the equation to the graph and from the graph to the equation using these two pieces. Instead of having to plot all of our different x values and y values and figuring out the line from that, we're going to see that you can just find the slope and y-intercept and write the equation right away. So if you find this useful, you can use this to solve any of these problems. If you don't get this at all really, you're still able to use the table method where you plug in whatever x values and find the y values so that you can find the graph of the line. Okay, so these are really just two different methods to do the same thing. Slope and y-intercept is much easier once you get it. The table makes a lot more sense though at first because you can see where the x and the y coordinates are coming from. Okay, so first we're just going to talk generally about what slope means. It's really the steepness of a line. When we talk about the steepness of a line, I'm really talking about how difficult it would be to climb. So I kind of want you to imagine a mountain. If you had a hill like this, that would be a very easy hill to climb. That's not very steep at all. This is extremely steep. That would be a very difficult mountain to climb. This has a bigger slope because it's steeper. It also has a positive slope because it's going up from left to right. From left to right, that goes uphill. A negative slope would go downhill from left to right. Okay, so in addition to positive and negative, we can actually find an exact number for this. And we're going to use the letter m to represent slope. To find the slope, we're going to do the rise divided by the run. Sometimes you'll see that left as a fraction. Sometimes you'll actually divide it out and find the slope. Either way, it's always the rise divided by the run or the rise over the run. The rise is how much we go up or down. And the run is how much it's going to the right. And all this really is counting so far. We're just going to count how much does it go up and how much does it go over. Okay? So the rise, we can also describe this as the change in y, how much the height is changing, and the run is the change in x, how much the horizontal distance is changing. So in this example, I'm going to use these 2 points. I'm going to use that one and that one, and I'm just going to count out the rise and run. It does not matter what 2 points you use, the slope remains the same throughout the entire line. So we're going to count the rise. I'm looking at the difference between this one and this one. How much did we jump up? Well, you can see there we jumped up 2 spaces. So the rise here is 2. The run is how much we go over. So we're starting out here, and we're going over to here. That's 1, 2, 3 spaces. The run is 3 here. So here our slope is 2/3. You might also see it as 0.6 repeated, but in general we're going to leave that as a fraction. Our rise over run is 2/3, so our slope is 2/3. I just want to stress that we can pick any points we want. Let's say I didn't think to pick those points. Let's say I picked that one and that one. It might not make sense that that's the same rise and run because clearly it's going up more. Let's count that out. That's going up 1, 2, 3, 4, 5, and it has to get to that level. That's 6. So our rise is 6. And our run, starting there, we're going over 1, 2, 3, 4, 5, 6, 7, 8, 9. So our rise over run here is 6/9. And that looks like it might be different, but really it's the same exact fraction. If we simplify that, that would give us the same thing. That would still give us 2/3. If we divide the top and the bottom by 3, that would give us the exact same fraction. We can really use any of these. Let's say I wanted to count from that same starting point to this point instead. I'm just using any 2 points on the line. I'm counting up 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So our rise over run is 4/6. If we divide by 2 on the top and divide by 2 on the bottom, we still get 2 divided by 3. The slope is the same no matter what 2 points you use. It doesn't matter. just going to do one more of those. Let's say we use this point and this point. We're going to go up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. So it's actually the exact same thing we just got. It's going to be 4 over 6, or 2/3. And what that's really saying is that for every 3 spaces it jumps over to the right, it's going to go up 2. So it tells us how quickly it's going up compared to how quickly it's going over to the right. That's what the slope is. The y-intercept is the second part of this graph. That's wherever the line crosses the y-axis. Intercept, when you think of an interception in football, it's where the defender crosses the path of the ball. It's where those two cross. That point is our y-intercept. It's the coordinates of the point. It's always going to be a 0 as the x value, and then some number for our y value. And the letter we use here is B. So on the first one, our y-intercept is right there. We're really just going to record the coordinates. It's hitting the y-axis at that point. That's our intersection. So that's 0, 2. Our y-intercept here, our intersection is at 0. We're not going left or right at all. We're just going up 1. That's 0, 1. We could also talk about the x-intercept. That's where it hits the x-axis. We're not going to worry so much about that right now. We're really looking at the y-intercept. That's 0, 3. So the reason these are so useful is that we have this general form of an equation, y equals mx plus b, where m is the slope and b is the y-intercept. You might have noticed on the last set of notes that all of our equations look like this. It might say something like this, where we have numbers in place of those two variables. Those represent our slope and our y-intercept. And I'll show you how to use those in a second. Let's just figure out how to pick them from the equation. So our slope on this first one, we're really just looking at the number that's in front of x. Our slope is 4. And our y-intercept is the number that comes after the x. We're going to include the sign with it, so that's a -9. On the next one, the number in front of the x, again, that's our slope. The m, the number in front of x, is our slope. So our m here is -2, and our y-intercept is this +6, so b is 6. On the next one, the number in front of the x is 1/2. That's our slope, and the y-intercept is 8. The last one, we're going to just pick out that number in front of the x, so m, our slope is -3/4. And our y-intercept is -12. All right, and these last two we're going to be working backwards. They're giving us the slope, and they're giving us the y-intercept. We just have to write that in the equation. So we're going to write y equals the m, that's 4, times the x, plus or minus this b. It depends on what the sign of it is. Since it's a -3, I'm going to write it as -3. On the last one, our m is 1/2, and our b is 7. So we're going to write y equals mx plus or minus b. Here we have a +7, so I'll write +7. So this is really the major use of it, these last two examples, really. From the graph, we can easily tell the slope by counting, and we can easily tell the y-intercept just by looking at where it hits the y-axis. We can figure out those two numbers really easily, so it lets us write this equation very quickly. Once we count out the rise over run, and we find the slope, we can really just put it in place of that m in the equation. Once we see the y-intercept, wherever it hits the y-axis, we just put that in place of the y-intercept in the equation, b in the equation. All right, so first thing we're going to do here, just find the slope. I'm going to pick out any 2 points on this line. I'm going to make my life as easy as possible by using points that are not decimals. I want to make sure they're on the grid line. So I'm going to look at this point, and I could also use this point. All right, so my rise over run is how much it's going up or down. It's going down 1, 2, 3 spaces. Since it's going down 3, my rise is -3. I'm going down 3. I have a rise of -3 and a run of, we're going over 1, 2 spaces. My run is 2. So my slope is -3 over 2. You could also write that as a decimal if you really want to, -1.5. I'm going to keep it as a fraction because usually we'll see it as a fraction. The y-intercept is even easier. We're really just looking at that coordinate. Where does it hit the y-axis? It hits at +3. The coordinates there are 0, 3. We're really just looking at that number. Our b is 3, our y-intercept is 3. To write that equation, we really just put that into this form, y equals mx plus b. So y equals -3/2 x plus 3. Y equals m, our slope, times x, plus our y-intercept. We're going to do the same thing on the next example. Again, we're just going to pick 2 points that are easy to see on the line. I'm going to use this one. If you can, use the y-intercept. It's always going to be the easiest. And I'm also going to use this point. So I'm going to count out my rise. That's how much it's going up. It goes up 1, 2, 3 spaces, so our rise is 3. And our run is how much it's going over. It just jumps over 1 space. So our rise over run is 3 over 1. Let's just simplify that. Let's just call our slope 3. We could leave that as a fraction if we wanted to, but we know that's just the number 3. The y-intercept is just this point. The coordinates there are 0, 2. So our y-intercept is 2. And the last step is just writing that into the equation. Y equals mx plus b, y equals 3x plus 2. One easy way to check to make sure that you did this correctly. Positive slopes go uphill. Negative slopes go downhill. That's a positive number, and it does go uphill. As we can see from the graph, it's going uphill. This one's going downhill, so we should have a negative slope like we do.